Next we have chemotaxis and name to chemotactic agents. Okay, chemotaxis, what does it mean? So chemo means chemical, taxin means to move towards that. Okay, so chemotaxis, that essentially means a cell moving towards a chemical. And what is that chemical? That chemical can be cytokines or interleukins, okay, complement C5a or any metabolite, arachidonic acid, leukotrienes, or maybe any chemical released from the bacteria like N-formyl methionine terminal amino acid, as I have highlighted here. Okay, so what does it mean? Essentially it means a cell, any cell, it can be a neutrophil or any WBC. Okay, so that cell is moving towards something, and how does it move, that we will see here. So first of all, in order to move the cell, there should be some attractants, right? There should be some attractants which is attracting that cell to move towards that particular thing. So there should be some source. I'll just show you this picture. So let's suppose here is the source. So the concentration of that chemokine is maximum here. Okay, just let's suppose ki your girlfriend is standing here, okay, and you are somewhere here, and you do not have eyes. Just like how the cells, they do not have eyes, so they cannot see where the thing is and they cannot move accordingly. They have to sense it. So if you do not have eyes, so the other route or the other way you can move towards your girlfriend is through the smell. So let's suppose your girlfriend is standing here. I just said let's suppose. Okay, so your girlfriend is standing here and she has put some perfume or something. So the nearest you go, the strength of that perfume smell will be highest, and the farthest you go, the smell will decrease gradually. Alright, so as the source is here and you are here, the cell is here, and see, as you can see, the concentration is increasing this way. So the cell, through some mechanism which is yet unknown, but they can understand the gradual increase in the concentration towards this particular direction. Okay, after that what happens? So once this cell sense the source, okay, at this maybe the direction of the source is towards east or south or whatever in the three-dimensional space. So once it senses that thing, what does it do? So here, as you see, all the chemotactic agents bind to specific 7 transmembrane G-coupled protein receptors on the surface of the leukocyte. So on the surface of the leukocyte, there is a receptor called as G-coupled receptor, which is a 7 transmembrane receptor. I will show you. See, this is 1, 2, 3, 4, 5, 6, 7. Forgot all this. Forget the right side. Just look at this part. So we have this 7 transmembrane receptor, that is G-coupled receptor. This is also called as metabotropic receptor. So we have two kind of receptors. One is ionotropic, the other one is metabotropic. Ionotropic is for the movement of the ions, sodium, calcium, chloride, potassium. That is other different kind of receptors. Here we have metabotropic receptors, in which we have G-coupled 7 transmembrane receptors, okay, also called as serpentine receptors, because it looks like snakes. That's how the name is given. So see here, N-formyl methionine peptidase is coming from where? Bacteria. Chemokines coming from endogenous, means within our body. Then there are some lipid mediators. All this, they come and attach here, and then there is cytoskeleton changes. What changes? Cytoskeleton changes. Inside the cytoplasm, there are actin and myosin filaments will be developed. Okay, once the activation of movement starts, then there will be development of the actin and myosin filament. Okay, then there is something called as what is that? With F it is. Okay, where is that? This thing. See, these are all the filaments. Okay, these filaments come to point, and then this is the cytoplasm. they come together and they form this kind of projections. Okay, and this kind of projections is called as philopodia. Okay, as we know what is pseudopodia, similarly we have the philopodia. So the G coupled receptors on the surface signal initiated from these receptors result in the activation of the secondary messenger that induce polymerization of the actin and the leading edge of the cell and localization of the myosin filament at the back. So something like this, there are actin filaments and myosin filaments all coming together to form all this kind of philopodia. See, F-actin, membrane curvature sensing proteins and everything. Okay, so this philopodia that pull the back of the cell in the direction of the extension, much as an automobile with front wheel drive is pulled by the wheels in the front. So as in the car, the front wheels they pull, right? Similarly, okay, I'll just show you the video, then you will understand. See, this is microscopic picture. See how the philopodia is coming outside, and this is the direction. This is the direction of the movement. So this is moving towards the left. This picture is taken directly from the robin. Okay, see here how the philopodias are formed. And how is this formed? Because of the actin and myosin filament, they get generated inside the cytoplasm. Okay, and then they extend like this. Just you can just see the video. This philopodia shown here are versatile cellular structures acting as sensory organ, locomotive tools, and even communication hubs. See, there is this actin, and how is this all actin and myosin filament is formed. See, several. This is just one philopodia. See, here is one, here is one. How they are moving. So this is how first the cytoplasm will move, then the contents of the cytoplasm, all the nucleus and the body will move. Okay, so this was that G coupled receptor. As you can see, there is cytoskeleton changes, then there is chemotaxis and migration. This is all part of the other topic called as inflammation. Okay, so there is this increased integrin avidity and addition of the molecule. This is all different thing. Done. And yeah, this is the inflammatory pathway again. So cell phospholipids that gets broken down, then there is formation of arachidonic acid. From the arachidonic acid, there is the cyclooxygenase enzyme which produces prostaglandins, prostaglandin H2, G2, which causes the production of the PGD2, PGE2, which causes chemotaxis. So all these are components of the chemotactic chemicals. And what do? They act like this source, okay, which attracts these leukocytes or cells, just like how your girlfriend attracts you, similarly. Okay.